This is the web apps track, and we have one of the last presentations of the day. We have Blended Threats in JavaScript, a plan for permanent network compromise, by Phil Purviance and Joshua Brachers. My name is Nathan Hamill. I'm the track chair for this track. So if you see me walking around, or if you have any questions, comments, complaints, whatever, feel free to track me down. Or maybe if in the future you're thinking about submitting something to Blackhat and you're kind of wondering what we look for, I would be more than happy to discuss that with you at length. So without further ado, I give you Blended Threats in JavaScript.
Are mics live yet?
All right, thank you everybody. I'm super excited to be here, so I hope you learn a lot from this presentation. I got a lot of stuff to show you. My name is Phil, and this is my colleague Josh, and we're going to be talking about blended threats in JavaScript, a plan for permanent network compromise. A little bit about ourselves. I'm a senior security consultant at HackersSecurity Consulting, web application security specialist. I also do bug bounty hunting for different companies, and you can find me on Twitter at SuperEver, and I have a blog at superever.com. And this is Josh.
Hey, what's up, everybody? Senior security consultant at HackersSecurity Consulting. I specialize in network penetration testing, so I used to get Phil a lot of shit. But beyond that, I'm a retro systems nerd, Apple IIes, whatever. And I try to be kind of a phone freak, but I'm not so great at it. Anyway, I'm Savan42 on Twitter. So, a little bit of background before we get started. So basically, cross-site scripting, CSRF, all that basic stuff, it's been around it's pretty much as long as the HTML. So this is the proverbial old dog. Obviously you're here and I'm here, and they're not going to give us a talk on cross-site scripting again. Well, at least I hope not. So I hope you learned something, and let's go forward. So traditional browser-based attacks often relied on a whole lot of user intervention. And as a network penetration tester, I could rarely count on that. I mean, if the scope's large enough and the client's large enough and there's a few hundred clients, then typically you can probably count on at least one person clicking the link. But it requires a lot of mandatory user intervention, somebody actually sticking the proverbial fork in the outlet. Social engineering, etc., user interaction, and nowadays I sort of hope that that problem's on its way to being solved, so I consider that as an attack vector unreliable and perhaps a bit far-fetched. Conversely, traditional network exploitation, with Windows desktops, Linux desktops, OS X, etc., has a sort of very predictable attack methodology. There's an exploit installed through social engineering or an unpatched vulnerability. From there, you exploit that, you pivot, you persist, you exfiltrate your data. You got to do whatever you need to do to get paid. Bad guys, good guys, whatever. The motivation is basically the same. But the thing about these types of attacks is that on a long enough timeline, they will be detected by antivirus. And so even though it's an arms race, eventually you could expect that this sort of attack is going to die or morph. And then we get into sort of blended threats, which are not a new concept, but basically, Trend Micro's definition is up there. But long story short, you use a series of attacks to get the ultimate goal along the kill chain. Basically, whatever it takes, multiple techniques to get your systems exploited. So, previous to now, there has been some amazing research in JavaScript and browser-based vulnerabilities, lots of different and novel techniques. But one thing I noticed as a penetration tester is I tend not to rely on these, because what I'm most interested in is the fastest penetration so that I can get in and get what matters to the business. So there's all these really cool technologies, but ultimately, nobody's really put them together to make them into a badass tactical weapon. And I think that that's what we're trying to do. So there's a lot of technologies that other amazing people have pioneered, but what we seek to do right now is turn them into a Lego weapon of mass destruction. A little over the top there, but you get what I'm saying. So the question is, how can traditional attacks, and specifically web-based attacks, go to the next level? We want to break free of the browser. We don't want to lose our shell as soon as the browser is closed, because the browser is the entryway into the network. It is not the end-all be-all. I don't really care about hacking Facebook accounts. I care about what matters to the corporation as a penetration tester. Because at this point, the times, they are changing. And as new technologies come out, there's going to be new classifications of vulnerabilities, but more importantly, the old classifications of vulnerabilities are being reproduced in ways that we hadn't figured out. There's a rush to get the newest, latest, greatest technology out, but we're not really learning from our mistakes. So why network devices? I mean, there's lots of multifunction printers, there's voice over IP phones, soft phones, etc. Lots of devices that are small, and generally we don't consider them to be a threat. Although I think that at the end of this discussion, hopefully you'll start to see things in a slightly different light. These devices, because they're purpose-built, tend to have a non-standard upgrade model. If it works out of the box, there's very little reason to check to make sure that there's a firmware update, which I think we need to get away from that paradigm, because they tend to be ignored by users just so long as they keep working. Set it and forget it. So ultimately, what this presentation is about is compromising these network devices using a combination of blended threats and JavaScript.
All right, so small office, home office routers in your network. It's more likely than you think, even in the enterprise. And Josh knows about this because he's been testing enterprise equipment for a long time. What happens is, home users, small businesses, they buy these devices because they're quick and easy, and it's something they can quickly set up in their home. But they don't want to necessarily configure them completely. Same thing with inside the enterprise, where they just want to get a quick jump start into whatever they're trying to do, whatever kind of QA testing they're going to perform. So a lot of the time, these devices just kind of get put onto the network without any kind of testing beforehand. But this isn't just about small routers and things like that. This potentially applies to any kind of network device. But we're going to use a few routers as examples here.
So one quick thing to understand is that maybe you've done the walkthrough and you understand that there are not any of these like lower cost Soho devices in your network. But the thing is over the years I've seen in penetration tests where you've got smaller groups. You've got the QAs, you've got the rogue engineer, whoever, basically, who doesn't give a crap about putting in an IT support ticket every time they need something small for maybe their miniature lab on their desks just so they can make sure they're bottom line. So believe it or not, these devices are out there. And you may not see them with a Kismet scan. You may not see them broadcasting SSIDs, or maybe even not. But for most often, they're actually there. So it's something you really need to take into consideration.
All right, this one too?
Sure. So in this situation, what would be the worst case scenario, okay? So you've got somebody, they forgot that there's that little Linksys under their desk, and they figure, well, if they use corporate network as their upstream or their gateway from these devices, what's the goal, right? So ultimately, what we want to do is do as much as possible with browser-based attacks. We want the end user to do all the work, because we're not doing it in a surreptitious way with a phishing email or something that does require some sort of manual intervention, just so far as they manage to find our code. And we'll get into that a little bit later, but you'd be surprised at how many different opportunities there are to view malicious JavaScript. And the interesting thing about this is it tends to evade detection. There are so many ways to obfuscate JavaScript that it's almost impractical for IPS and IDS systems and very on-the-ball network administrators and blue teams to be able to understand this stuff. And ultimately, the end goal is profit. If you're a penetration tester, you get paid by showing the corporations what the risk really is. And if you're a bad guy, the bottom line is get paid, get out of there. That's it. So this is basically what we propose. Essentially, the first thing we need to do is deployment. And I think over the years we've sort of discussed there's various different ways to deploy it. There is the standard email phishing. There are, you could compromise something internal to ensure that most people are going to be able to see this device, right? Easy enough. Deployment isn't really the issue. It's a little easier to detect in some cases, but it depends. It depends on what the actual attack vector is.
The thing is, there's so many ways.
So we can start with ad networks. A while back, Yahoo Ads was compromised, and they didn't realize what they were actually submitting malicious ads. So that's one way you can go into it. Another one is these file sharing sites. Mega Upload, they've had their troubles, but it's not like they're the only one like that. And what's really cool about sites like this is if you're not willing to fork over the dough to have a platinum account, you have to deal with something like this wait, 60 seconds, 30 seconds, whatever. If you want to download the latest episode of Jersey Shore, you're probably going to have to wait at least a minute unless you're willing to cough up a couple of dollars. In this case, 37 seconds. And what's badass about that is that actually gives us a big enough window, more than enough time to actually execute these vulnerabilities in the browser, or the user is expecting at this point for their browser to be sitting, waiting for their time so they can get the latest episode of Game of Thrones or whatever. Pick your favorite show. And then another opportunity is these free online surveys. So I try to avoid it, but I need Facebook to send pics of my kids to my various families spread all over the country. And there's not a week that goes by that I don't get one of these offers for these damn surveys from these people believing that if they send this crap to enough people that they're going to get a free iPad out of it, or maybe they take 10 minutes. But most of these tend to be malicious. And it's a really awesome way to send malicious code because these people aren't concerned about security. They want the iPad. Another opportunity is, of course, social networks. At this point, there are so many social networks that even though Facebook is arguably one of the biggest ones out there, there's millions of them. And even though Facebook's got a badass bug bounty right now where people are spending a lot of time trying to track down these vulnerabilities, and let's be honest with them, most of them are Java-based, etc., cross-site scripting vulnerabilities. But they're not the only one. There's a lot of them that are in a lot of use. And then there's, of course, malicious search engine optimization. There's domain fuzzing. So instead of MySpace, it's rnyspace.com, lookalike domains, etc. And these things tend to be designed to steal your information, steal your traffic for ad generation, or in this case, we expect to push malicious code. So if you don't believe me, and I understand that, right? But consider this. I assume that at least some of you have a Facebook account. Even if you don't want to admit it, I'm not going to ask you to raise your hands. But think about this. On Snopes.com by itself, there are 180 different entries that revolve around Facebook. The whole, if you click like, Bill Gates is going to donate $1,000 for every like to needy kids in Zimbabwe or whatever, right? And the same thing goes for MySpace. There's at least 30 entries. But basically, if you spend enough time on a social network, you are invariably going to be inundated with this crap because people have good intentions. They want to believe that it's true. I mean, consider this. All of our families, all of our non-technical members and people that we went to high school, they all post this stuff. Like just last week, 90 people sent me, if you click this, you're going to get a free trip to Disneyland. So there's more than enough opportunities for your friends and the people that you trust to bypass the trust model and get you to click this malicious code. So ultimately, deployment of this code is fairly trivial.
All right, so there's millions of ways to get this JavaScript code, if you have some malicious code out there, to run on a user's browser. All right. But the question is, once deployed, what do you do? All right, well, the key to these types of attacks is to target a rich environment. You want to get as many people as possible because there's probably going to be a high failure rate. But you want to get the optimal attack surface, meaning you want to get as many devices and as many users hit as possible. So what do you do once it starts running? There's a lot of research out there on network scanning using JavaScript. It's been around for a few years. If you're not familiar with it, basically JavaScript-based network scanners are able to detect devices on your network and whether they're live or not. All right, there's several known techniques. Each has their own pros and cons. Some are faster and some are slower. But it really demonstrates that there's the potential for lightning-fast enumeration of network devices. All right, so here's just one example, JS scan. It's really great. It's just a proof of concept, right? You put in an IP address on your network and you put in a range and it starts scanning and looking for open ports and seeing what's open. I did this at my house and it's like, oh, sure enough, port 80 is up on 192.168.1.1. Here's another great one, but this one actually uses a couple different techniques, different than the previous. And this is JS Recon. And here's one of my favorite, JS LAN Scanner by Gareth Hayes. And it actually is able to detect what devices you have there. All right, so how is this even possible? Like, how can stuff on the internet find out what devices you have on your internal network. They're supposed to be separate, right? Well, web browsers don't really differentiate between resources located on the internet and resources located on the internal network. If you have a web page that sends a request to an internal IP address, 192.168.1.1, it sends that request. It doesn't really care. All right, so how would you detect what's there? One way of doing it is with iframes and image tags. You can use JavaScript on load and on error events, and that's how you can determine whether the image was there or wasn't, or if the request was responded to or not. All right. You can also take advantage of HTML5 features. We'll get into more of that later, but cross-origin requests and WebSockets can really speed things up. All right, and here's just an example of what that code looks like. All right, so one of the things that's really cool is by attempting to load multiple resources within a large range of IP addresses, JavaScript can actually determine what hosts are up and which ones are unavailable. So if you have a list of default IP addresses used by the common manufacturers, and you're able to recognize that, well, you're able to determine a lot more. You're able to determine what device is actually on that network. Right? So there's some JavaScript-based scanners that can use images and other resources to fingerprint the device on your network. For example, I said JS LAN Scanner was a good one. It has a database of nearly 200 devices, and it's able to enumerate them by comparing the existence or absence of certain images on those devices. A lot of them might have /images/linksys.jpg or netgear.jpg or something like that, where it's able to see that image without even authenticating and being able to say, okay, well, I know this is a Netgear device or whatever vendor, right? And go from there. So an attacker could fine-tune these types of utilities and just make them so much better, because these obviously weren't projects that were paid for or government sponsored or anything like that. They were just projects done in people's free time, but they're really cool proof of concepts. I had a couple ideas on how these could actually be made better. What are you going to do? Scan a whole range of IP addresses and hope you're able to get through all of them? There's a lot of IP addresses, right? Especially
if you assume, you have to make the assumption that all these devices are on 192.168.1. If you're a different octet than that, then ultimately this attack is nerfed until...
Right. But I found out that some devices, you don't necessarily need to log into them using the IP address. Netgear routers, for example, they put in a DNS record, so if you go to www.routerlogin.net, it redirects you to that internal network router. Right? So you could use a similar technique. Instead of putting an IP address there, you're putting www.routerlogin.net and testing what you can find there. Another way to do it is with Bonjour, often called MDNS or zero configuration. And what happens with that is the device registers itself on the network, gives itself a name, and it kind of works like a domain name, right? So FreeNAS, which is a network attached storage system that's available on the internet, it registers as a Bonjour service, so you can connect to it at freenas.local. That means you don't need to know the IP address to get to it once again. So these scanners could also create a list of those kinds of devices and being able to enumerate what's on your network without even trying to guess the IP address or any worries about, you're using a strange subnet or something like that. But there are some limitations to what you can do with JavaScript, and I thought I'd go over them a little bit. And one of the main ones is that you can't really determine the client's internal IP address using JavaScript without using like non-JavaScript code like Java or Flash or something like that. And it's easy enough to do with that, but this talk we really want to get into the core of what's in the web browser, right? You don't need to have any kind of extra extensions to do what we're going to go over. All right, so at that point, it's all about gaining control. You've found victims, you've scanned their networks, and you've determined what devices they have. So how do you maintain your control within that network? One trick about these devices is the authentication on them. You may want to do some kind of CSRF attack or something like that. This is just an example of some of those authentication pages. They're all a little bit different. Some router vendors, or network device vendors, they do it right. Here's an example of one where it explicitly says, okay, before you can use this, set a secure password. Make sure it has some numbers and special characters in it before you can do anything else. but most don't do it right. All right, routerpasswords.com, awesome website. You put in the make and model and you get the default username and password for that device. This stuff is public information. It's all available. There's huge databases of it. So if you're able to find out what device they have, you can make a probable guess of what their password might be. Another great website, let's say their password has been changed and you weren't able to guess it right away. Routerpwn.com is another great website where they have proof of concepts for various network devices, including authentication bypasses, where at that point you don't need to worry about the authentication page. You can just get around it. All right, so how does authentication on these devices work? Most of them use basic authentication, which sends a special header along with the request. It says authorization basic, and then it has the username, password, and it's base64 encoded. Another common way is to use traditional form post authentication. All right. So how would you CSRF that? How would you cause a user to log into their device? Because you already know what device it is. Well, you can just create an image tag like this. And you set the source to that remote device, and you put http://username: password @ and then the IP address. And then if it's successful, it will log in. Okay, well what about if they're using a form post instead of basic authentication? Well, this is what CSRF for that would look like. It can, both of these can all happen in the background, and the victim would be none the wiser of what's going on. And another way to do it, if there was cross-site scripting or another vulnerability like that on the router, you could do really cool things like set extra headers. You can just simply put an authorization basic header in the next request being sent to the device. And maybe you'll try a few of those and see what kinds of responses you get back. So you can see here that I have you see the base64 is that long YWR string, and that's actually admin:admin in base64. But what if you could brute force the device and find out a little bit more about what's on it by guessing the password? All right, so what happens when you actually submit these requests that I just talked about? Well, if the request is successful, you get a 200 OK. Right. If the request is unsuccessful, you get a 401 unauthorized. What happens when you get that? You get a dialog box that asks you to enter in the correct credentials. All right, right away, that's going to alert the victim that something's going on, something's up. And at the very least, it's going to slow down your attack. However, I saw this the other day. It was a bug report for Chromium. Zoom in there a little bit. I'm not sure if you can see it. But basically, they're saying that it's a generic bug affecting all browsers, where there's an issue where a lot of websites allow you to set arbitrary image source parameters. So you can set it anywhere. And the issue is that if the source parameter refers to a resource that responds with a 401 header, just like I said earlier, indicating basic auth, the browser will pop up a dialog. And it might be abused because the user won't be aware of where this information is actually going. So if you're on Facebook.com and a user sees a dialog box, enter your username and password, they may think it's asking for their Facebook information, but now instead they just send it to the attacker. So I mean, it sounds like a legitimate problem, right? So I found out that with Chromium 13, they decided to fix this problem. Blocking HTTP auth for sub-resource loads. Basically what they ended up doing is it says to resolve this, we've blocked HTTP basic auth for sub-resource loads where the resource origin is different to the top level URL bar origin. We also added a command line switch in case you don't like this. But what does that mean? That means that you can send as many requests as you want without ever getting that message saying you put in the wrong password, please enter the correct one. Which is great because you can use asynchronous JavaScript resource requests to send out thousands of these. All right? So in an attack example, you would have a page. It would set up these resources and request them. And when it found one that actually returned an onload event, you would stop it from going any further, and you would have the correct password. All right, so In my testing, I was actually able to get Chrome to do about 100 password attempts against a device in about 2 seconds. Pretty fast. Chrome's a fast browser, right? I mean, that's what it's all about. And I'm going to give you a demo now of that. Let me make sure this guy's plugged in. I brought with me here a Linksys WRT54GL. It's a great test device. I mean, they still sell them. You know, they haven't patched them in a long time. There's a lot of open source stuff available for it, for you to, you know, install your own software on it, replace it, things like that. So it's a great little test device.
And it's important to notice that although we're using this device because it's readily available and fairly common, the same technique offers for most of them. And in case you're worried, because we are, there were many liquid offerings to the demo gods over the weekend, so hopefully you enjoy it. Yeah,
we're not wizards, so maybe we picked the easiest one out there, but I'm sure there's people out there that can do a lot more complicated stuff than us. All right, well, let me make sure that device is available here. I'm going to create a new Chrome private browsing window and try to access it. And what I'm showing you here is that we're not logged into this device. I try to go to it, and it says, no, you need a password to get past this page. For when unauthorized, of course. So I created a page to go through a whole list of script resource requests with different passwords on them. And to kind of better demonstrate this, rather than 100, because that only takes 2 seconds, what kind of demo is that? I gave it 1,000-something requests. All right, so here's my brute force technique. We're going to load up the network browser here so you can see what's going on. And when we get the right one, it's going to pop up on the side over here. And if you look down here, we've already got about 600 requests. These are all errors saying, nope, didn't load, didn't load, didn't load, didn't load, didn't load, didn't load. About 900 right now. Like I said, I put the correct password near the very end of the list. Oh, boom, we got it. Username admin, password admin. All right. So with Chrome, you can actually get a pretty good technique to brute force against a password.
And it's worth noting that if you are a pen tester or someone who's specifically targeting an individual, then you can start to do a little bit more open source intelligence gathering and make an intelligent word list so that you're not just throwing the whole dictionary at it. You're actually increasing your likelihood of penetrating and hopefully under 1,000 requests. Yep.
Still don't believe me that it worked. I'm going to go back to that router page again. Oh, look, I'm logged in now, which means the attacker is able to access anything that they see when you're logged in. So here's that example that I was showing you where it's sent about 100 requests, and you can look at the time log here, and on the bottom right you see that 100 requests in just 1.74 seconds. It looked like the one that was actually successful took a little bit longer. All right, so now you're in the device. You had the victim log into the device without them ever having to enter the username and password to get you in. Some of the previous attacks, that's pretty much where they stopped. We had the user log into their device and then we CSRF'd them, things like that. But we can do all that in an automated fashion. So now it's all about how do we exploit this? How do we compromise that device? Josh?
Yeah, so let me just jump in real quick. With a lot of these devices, and you're running a variety of operating systems based on them. There's proprietary systems, VxWorks, there's Linux-based firmwares, and there's other things, multifunction printers, etc., that have their own brand. But what I like to pick on to prove the concept right now is Linux-based firmwares. And there's some great tools out there that I cannot recommend highly enough. My favorite right now is Firmware ModKit because it's fairly vendor agnostic. It doesn't care if it's Linksys or Cisco, not to pick on them, but a variety of other firmwares as well. And basically what it does is it analyzes the binary, it determines things it looks for, like LZMA, compression, file systems, and does a damn good job of decompressing the devices, giving you basically a file system that you're free to tweak as you like. And you don't even need to run these in an emulator or have a cross-compile toolchain. And the majority of these devices are running on common architecture, ARM, MIPS, etc. And then furthermore, there are WRT54G Linksys specific devices that if that's all you're really going after, then that's a good way to go. And then of course there's DDWRT, which is a proper router replacement firmware, and it's actually excellent. So we're gonna pick on them a little bit, but not because of anything that they've done wrong, just how common and easy they are to modify. So how, once we have this rogue firmware that we spent a weekend and a 6-pack of beer or more developing, okay, we've got it, great. So how do we do the install?
All right, so a little bit of, if anyone has ever looked into how do I CSRF files over the internet, how do I do that kind of thing, you've probably ran into the case that people have done in the past, but with Flash extensions. There's been some bugs in Flash, and as far as I know, they've been patched up. There might be some more, but I'm not aware of any open vulnerabilities in there. Browsers also don't give a lot of control over the request, so if you wanted to do CSRF of file types and binaries and things like that, you're kind of stuck. They're not able to correctly handle binaries and form fields unless they're going through their normal file API. And if you try to send it through JavaScript, JavaScript completely mangles the binary data. Well, that was until this came along and all the browser vendors decided they want to add a lot of features to their browsers. Woo! All right, so with all these new features, can we take over an entire network by combining JavaScript attacks? Yes. All right, so let me just go over the basic steps of deploying the firmware. Similar to, we're using a CSRF technique, right? So the victim visits the attack site, and the attack site instructs them to access malicious firmware. But using these new JavaScript APIs, we're able to get it to download that firmware and store it in memory. And it keeps it there.
And this is all transparent to the user. We're still talking zero user interaction.
Absolutely. There's no file download alert or anything like that. So the new firmware that you have is going to be stored in memory, and then you can resend it wherever you want. So in this case, we're going to resend it internally to the user's network, to the device that we just logged into. All right, and I have a demo for that too. All right, so for this technique, once again, we're using the Linksys WRT54GL based on Linux. There's the DDWRT software for it that is pretty configurable. You're allowed to pretty much do whatever you want with it. It adds a bunch of features and things like that, but it's great as a demonstration. So I created a little test page here. And yes, clicking the run attack button can brick devices. So you have to be careful.
And it's important to mention that a bad guy looking for return over investment versus a specific targeted attack, that is to say that you may not really necessarily want to use these in penetration tests where the scope does not include destroying the enterprise network. But bad guys tend to not care about that.
So let me just remind you what that Linksys interface looks like, so familiar. And I'm going to click Run Attack. And of course, this can all be done in the background. And I have a little bit of information here. Cool thing about cross-origin resource sharing is you can get information like that. You get that progress bar going on because it's actually getting the information from the attacker domain. But we can see here that I can actually tell a lot of information, even though cross-origin resource sharing is supposed to prevent you from doing a lot of things. You're not supposed to be able to see the response. So it's like, how can this kind of stuff work? All right, so we see the steps: downloading malicious firmware received, creating a new CSRF request, and now it's uploading that malicious firmware to the Linksys device. All right, so this takes a little bit. It's a couple meg download, couple meg upload, and right now it's sitting there and waiting for a response. And the thing about CORS is the browser and JavaScript, without special headers being provided by this device, which it's not going to have because it's an older device before HTML5 even was a word. It's not going to be able to see the response. But when the request fails, it's going to error out. And that's going to tell us that it's finished.
And one thing to consider is while this appears to be taking a little bit longer, and most of us would probably wonder why this is taking so long, on sites like Mega Upload, Rapid Share, etc., it's pretty standard requirement to make you wait at least 30 seconds. So it's not like this is ringing any bells right now in those situations.
Absolutely, and once that kind of attack got sent all the way through the wire, I know it took a while for it to time out, but once it gets all the way sent through, I mean, you're done at that point. You can, the user can shut down their browser. It doesn't matter because the attack is over with and the device has been fully compromised. So with this device, it actually has a little problem where it needs to be rebooted here. So I'm going to do a quick reboot of it.
And that's generally specific to these devices. Depending on the make, menu, manufacturer, there are oftentimes APIs that will allow you to actually reboot the device silently. So for the purposes of this demo, we're unplugging it, but generally speaking, that's not always a limitation.
And we'll give that a minute to boot up here.
So how's your Blackhat going so far? Good? Yeah, good. All right, is that right? Is that right? Oh. I don't know who this is, but I'm totally stealing it.
Takes a while to load. I think we're going to move on, and then we'll show you in a little bit because we've got to make sure we stay in time here. But what's going to happen is you're going to see the DDWRT software there. Here's how that works. Here's some script. If once you get these slides later on, not from the DVD, but from my website or elsewhere, this is pretty much what's going on. We have a new XML HTTP request. We set it to grab the firmware. That's the bad firmware.bin, of course. We set override MIME type. What that tells it to do is not to mess with the data that comes to it. Normally the browser's going to be like, oh, this is UTF-8 encoding or some other character set. So I'm going to do something weird to it. No, this tells it, don't do anything. All right? So we send that initial request to the attacker's website, which of course gives us permission to see the response. So once you get that response, you run another XML HTTP request. This time you're opening it to the network device. There's a flag with credentials. If you set that to true, any credentials that the user has on that domain are sent along with the request, and that includes basic authentication. And then at the end, you have the set request header. And what we're doing here is we're actually spoofing what a multi-part form data request looks like. You're able to have so much control using these types of requests that you can make it look just like you used a form submission. And at the end, of course, we have our image tag, which is automatically going to log the user into the device. And then once it airs out for whatever reason, when it finds out that's not a real image in this case, that's when it's going to start running the script. But the cool thing is you can see all the code for this on GitHub. I put it up there today. So I'm calling this a DDWRT install tool because if your friends are like, hey, I don't know how to get DDWRT installed on my computer, you can just say, okay, go to this website and click start.
Kind of like using Metasploit for tech support for your family. Yes. It actually works really well, by the way.
All right, so that's github.com superever DDWRT install tool. All right, now post-exploitation, this part's really interesting.
Okay. So right now what we've explained is basically using network devices, and for right now our demo is small office, home office routers. You're like, big deal. Okay, one of those gets compromised and we eventually figure it out, we throw it out. But what's interesting about this is that you've essentially turned in these Soho devices at home in the VPN or in the device in the QA and engineering lab into a full-blown Linux attack framework. And generally speaking, it will still look and act the same way. So you start thinking about, well, okay, no big deal. I've got Cisco devices, right? This attack doesn't really matter because for the most part, you can't upload firmware for Cisco devices. Okay, fair enough. But who knows what happens when you crash or DOS a Cisco device? Typically, it'll reboot and it'll go through an order of operations of places to look for backups. And one of those backups that it looks for tends to be TFTP, right? Okay, well now we've got a TFTP server that's light as hell, stored on this device, and we can ARP at that point. So if we know by network traffic sniffing or man-in-the-middle attacks that Cisco was looking for this one IP address, ARP spoofing, they come to us. Their TFTP or their Cisco configuration goes to us, and now we can do some cool stuff like opening GRE tunnels to our attack server in some Eastern European country or etc. or pen testing server. But also, if a device like this has a wireless access point, and several of them do, well then you can start using tools like Airbase NG, where you're able to actually clone access points that are listening for every single beacon request from a client looking for a specific favorite listed access point, broadcast that, and when they communicate, number one, if they're dual homed on the corporate network over Ethernet, bangarang. But number two, once they're using you as an outbound gateway, you can then start doing cool stuff like injecting the iframes for every single one of these attacks, every request that they make. And then if they take that home, etc., this code tends to propagate. So it's really interesting from a bad guy perspective. You insert the payload into all requests and responses, and you're good to go. Furthermore, because we own the device at this point, logging is out the window. There's nothing that we need to worry about anymore. Really cool stuff like pivoting via SSH tunnel or an open VPN server, etc. Basically, persistence in a nearly undetectable way. Okay, well now you're saying, well no, I'm port scanning these devices. Obviously there's a port open at 2222 that I did not authorize. Something's awry, right? Well, not necessarily, because you already own the firmware. You can do whatever the hell you want with it. It can be some sort of out-of-band command and control system over IRC, for example, runs over SSL, and let's be honest, a lot of the IDS, IPS systems out there just have a blind spot for SSL, and it's sort of the dirty little secret. Not to say that all of them can't do that, but it's a common problem. And then there's reverse SSH shells, and again, using non-standard ports over 443, over DNS, etc., where common firewalls are expecting outbound traffic from work to go to these ports, then it tends to be a little bit more surreptitious. But let's say you're attacking a remote user. Maybe the CFO likes to work from his Bahamas summer home or whatever, and he's got one of these bad boys. Well, we don't have to worry about port forwarding and stuff anymore, because now that we own the edge device in this kit situation, we can open up whatever the hell port we want. And so you could do something a little bit more surreptitious, where you don't have to worry about the random script kiddie going through, finding it, and getting your cover blown, because then you can start to implement things like port knocking, etc., where the port, the ingress bind port, will never be seen unless you know the secret password. And at that point, with propagation, you're able to do a lot of really cool things. So, and
don't forget that IPSs and IDSs are also often controlled through a web interface. They may have these problems too.
Exactly.
What happens if your IDS is compromised?
And once you've got these reverse controls, we can easily upload our own new functionality. And what more is that we can actually disable the built-in firmware upload functionality, so we don't even have to worry about the vendor pushing out some new code and uploading it. So if the client tries to go ahead and fix it, we just throw it out. We could, if you want to get crazy and code this, you can rev the version number itself in the malicious firmware. It's up to your imagination and your skill level at that point. So at this point, ironically, the paradigm shift is such that most often, the older the software is, the more likely you are to be vulnerable. But with cross-site file upload and the HTML5 integration, it's a total shift, because the more current your browser is, the more likely you are to be vulnerable in some of these situations.
IE10 supports cores. All right, so what are some of the pros of an attack like this? And once again, this is just kind of something that can be done. That's what we want to prove to you guys, that this could be done if somebody spent enough time and built a large enough toolkit. This could be done. But some of the pros of it is that it doesn't rely on the browser remaining open when the attack completes. You're compromising another device on that network, not that user's computer. You can also propagate deeper into that network. Once you get there, you'll have better persistence. You're going to be harder to discover, and you're going to be immune to antivirus. These devices don't run antivirus, so you can pretty much do whatever you want. You can change the interface up. You can hide elements from the user when they log in.
Furthermore, because these devices are never actually written to the client's computer system, they typically are not detected by traditional desktop antivirus systems.
Some of the cons out there. Well, with so many devices and network equipment out there, it could be difficult to build a wide enough range of exploits for these. They're all unique, right? Except a lot of exploit developers, they want to program for Windows, right? It's easy, you write it once and it writes on a ton of computers. It takes a lot of extra effort and pre-work to do this. And victims may not be running latest browsers, maybe they're still running older versions. And if the devices really do have unique passwords, the compromise isn't guaranteed. So you may have a pretty low ratio of success to not.
Without doing the necessary open source intelligence gathering in order to determine which passwords your target is more likely to use. But if you're going for mass propagation, this can tend to be a limiting factor compared to the Windows exploit du jour.
All right, so what about mitigation? So one thing that kind of stunned me is that sites shouldn't be able to access private IP addresses on your network. I mean, we know what IP addresses these are because they're in RFC 5735. Cross-origin resource sharing, maybe it could be even more restrictive. I don't think any developer is using it in this way today to legitimately send files over the air without needing to see the response. And of course, these devices need CSRF protection. I mean, it's been a long time since CSRF was, disclosed, and they're still not updating their software to take care of it. It's not that high enough of a priority. A little bit more mitigation on that is these devices, what if they had automatic updates? Why not? Your Windows or your Mac has automatic updates. Why not your network devices too? Signed firmware modules. That sounds simple, right? You want to make sure that the firmware going onto the device came from the manufacturer. And for enterprise, they may want to look at JavaScript a little bit differently. It has a lot of power now that it's getting all these features. So you may want to treat it more like a third-party plugin like Java. And I don't know if it's even possible, but AV vendors may want to create some heuristics for cross-site file uploads so that they can detect it in the wild. All right, so really what I want you to get out of this is 4 simple facts. Devices on your network have vulnerabilities, and if you don't think so, you're kidding yourself. Your web browser allows attack sites to access those devices. All right? Attackers can use CSRF to log into those devices, and then once they log in, they can replace the operating system on that device for their malicious purposes and maintain control indefinitely. All right, so this talk, it came from a lot of information from a lot of other great researchers, so I want to give them credit here.
A lot of brilliant work.
We added a few new things to it, we put a few things together, but there's a lot of good research that went into it beforehand. So thanks to these guys.
Wait, no, specific shout outs. Go back for a second because I feel like it's worth saying out loud. Jeremiah Grossman's Blackhat 2006 talk, the DEF CON 17 CSRF talk with McKee and Bailey, the remote attacks against Soho routers from Hefner in 2010, and specifically Kodowitz is doing some really cool stuff that sort of led to this specific research. And there's a lot of other people, but seriously, we wouldn't be here without them standing on the shoulders of giants. So if you guys are in the audience, thank you.
Thank you.
So we have a couple extra minutes for questions, and if you're brave enough to stand up and hassle us, we've got some cool AppSec swag. You can choose between challenge coins or t-shirts. Any questions?
Yeah. Yes, we just used routers as an example.
The question was, we specifically focused in this use case on routers, and specifically here, Soho routers. And is this possible using other devices? And the answer is hell yes, but we would have spent 50 minutes discussing all of the different possibilities. And to be quite honest, it was the easiest to prove the proof of concept with this. But it absolutely is. The limitation is only your familiarity, your skill, and your imagination. You want a coin or do you want a shirt? There you go, man. Yeah.
Let's check it out.
There it is.
Yep.
Any other questions real fast? Yeah. I'm sorry? Mobile browser.
So I didn't do any testing specifically. The question was, have we tested this on mobile browsers to see if they had the same problems? Mobile browsers are quickly catching up to the desktop browsers. Although it would be inconvenient for me to do this kind of testing, it looks completely possible, especially since they want the mobile devices to mirror the desktop ones.
Shirt or challenge coin?
Yeah.
Okay, what size? Challenge coin? Yeah. Yeah. Well, here, I'll show you. This is challenge coin, good size, double size.
So the question is it putting too much effort to put this large package of data onto these devices? Is that too much effort? I think it's quite a lot of effort, but you get quite a lot back because that device isn't going to be fixed by antivirus. It's not going to be caught. And in an attack where you had 1 million users run this code, if your database of vulnerable devices and vulnerabilities and firmwares was big enough beforehand, you can get a higher rate of success there. And once you have those devices in your control, they stay that way. Yeah. My slides will be available on my website, superevr.com.
Right, Mia. Okay. And
yes. Okay. They're not there right now, but they will be tonight.
So I think we're about ready to get our asses kicked off stage. So if you have any other questions, yeah, talk to us.
Yeah, just follow us. I think we're going to walk back to the speaker room.
Yeah, we'll walk back to the speaker room and bring all the swag with us.
But thank you very much, guys.